All right, hello everyone. Welcome to another webinar hosted by Seek Thermal and Andy Starnes of Insight Fire Training. Andy brings over 30 years of experience from his career as a battalion chief in Charlotte, North Carolina. We also have a special guest today, Webb Marshall. Webb is a lieutenant at the Jackson Trail Fire Department. He's also the vice president of business and product development at Full Circle Lithium, where they specialize in lithium fire suppression technology. So Andy and Webb, thank you for being here today to talk with everyone about the dangers of lithium-ion battery fires and incorrect thermal imaging usage. If you guys have any questions, please just type them in the chat. We'll do our best to answer them in a timely manner throughout this webinar. With that being said, I hope everyone enjoys it, and Andy, take it away.
Thank you, Jordan. I just want to add that our special guest today is a good friend of mine. He's an amazing human being, number one, good man, good husband, good dad, and does a ton of things that are not listed here. So please look him up after this is over. He's a rain man of information. I'm honored to have him on here and listen to him. I give him credit. A few years ago, I was at a conference and he was doing a class on boots. And I sat in because he was my friend. I was like, what am I going to learn about boots? And I took 12 pages of notes on boots and came up and shook his hand and said, that's probably one of the finest presentations I've ever heard. You had me. That just shows his level of knowledge and ability to convey the information. So I'm very honored to have you here, Webb. Thank you for taking your time. You're an extremely busy man. I appreciate it.
Thanks, Andy. I'm really excited about the conversation today.
You guys know me, but I won't go any further in the stuff you've heard from me. So one of the things I'm going to try to do in the future is we're going to try to cycle in some special guests like Webb here, so you can get some very interesting topics that are applicable to your world and experientially relevant to the fire service today. So first thing we have to talk about, ladies and gentlemen, is that we are talking about two very important topics: EV, lithium-ion fires, and thermal imaging, do's and don'ts. Some information that's not well known. One of the problems we have in thermal imaging is this study we've shared with you before shows that the majority of the fire service has had very little to no training on this. And I think it's even worse when we come to the EV side, which in lithium-ion, which Webb will share with us. But I want you to understand that one of the biggest issues or misconceptions with the device itself is they're using these devices to try to measure temperature or see things they were not intended to do. And one of those is trying to measure temperature, for example. If you follow our work, you know that we are very big on getting you to see heat and not use this as a thermometer. We definitely want you to advocate to look with the device to see what you may see, but understand there are contraindications and the device does not see everything. There are thousands of different models of thermal imaging cameras, not just fire service ones, which we'll briefly discuss. But you need to understand that the world where we're living in now is not a standard Class A fire. And we're dealing with things that produce gases and things that we didn't have to deal with before that these cameras are not going to detect. And Webb will share with us some of that information. But just if you haven't had any training, please check out this survey and check out our free resources on our website and along on YouTube. We've provided thousands of hours of training that people can use, and we don't hold back. We want you to have it. So please make sure you check it out. This will be about 20 hours of webinars after this that we have available for you to use. Thanks to Seek Thermal sponsoring this. Seek Thermal currently makes this group of cameras for the fire service. If you're interested in any of those, the QR codes at the bottom will take you to pre-recorded webinars we've done to educate you on those, or if you're currently using them, you may check those out. They make situational awareness thermal imaging cameras and decision-making cameras. However, these are not optical gas imaging cameras. These do not detect gases in the range that we're going to be looking at today. So we want you to understand that, because thermal imaging detects certain things, which is heat. We talk about what's being detected and what's not being detected. Your camera is programmed to measure heat in a specific range, long wave infrared, and it displays it based on algorithms that the engineers program into the device. And that also varies depending on where you're standing, what's between you and the target, what the surface looks like, what the reflective surface, is there any atmospheric attenuation, am I standing directly in line with the target, and the end user itself, am I properly interpreting this data or using an incorrect thermal color palette that may not be applicable to this particular application. For example, this is an example of a gray and white thermal layer that is extremely hot that's hitting these firefighters in the head. But because it's not colorized, firefighters are ignoring it. The absence of color is not the absence of heat. You're going to see a lot of absence of things that should concern you today that makes you realize there's more going on than meets the eye. It's my favorite quote from the Transformer movie. And when we look at cameras themselves, I want you to think about this as we go forward. Your eye only sees less than 1% of all light around us. We're looking at between 0.4 to 0.7 nanometers. While there's so much else going on around here, there's gamma rays, X-rays, ultraviolet, infrared. And in infrared itself, it's broken down into short, midwave, and long wave. Then we have microwaves, we have radio waves, we have all this stuff going on around us, and we see less than 1% of that. And your camera, your fire service camera, picks up 7 to 14 microns. That's what that little UM is. And those are picking it up off of surfaces themselves to transfer across a surface or in that area in front of you. But this does not include gases. There are certain gases that fit in that spectral range, but we cannot guarantee you specifically they will detect them verbatim or exactly. We are detecting heat transfer. We're not detecting gas vapor clouds. If you'd like to learn more about that, I challenge you to look up optical gas imaging and look at the different cameras that are filtered specifically to measure certain gases. They are not, one size fits all problem. So understand that these devices are measuring surfaces and they are not designed to see through things. They are qualitative in nature, which is designed to pick up patterns, contrast, diagnostic details. They are grossly inaccurate in temperature measurement. In this picture here, where we're looking into a container in Germany, we have a spot temperature measurement of 91 degrees Fahrenheit, where if we read the actual relative heat indicator on the side, we're reading between 150 to 300 degrees apparent temperatures. Apparent temperatures are a gigantic estimate based on those pre-programmed variables that we can't control. They put in certain things and leave them there. You don't have time to adjust them. So when Webb and I talked about this before, we've come across many people using these as thermometers. And we don't want you to become injured or worse by pointing these at a device thinking, oh, it's only reading 60 degrees, it's good. We're going to show you why that's a bad idea, that you need to look at the entire scene, not just the camera. Use your training, use your brain, trust your gut, and all the education he's going to share with you today of why we don't want to use these in an incorrect way that could lead to injury or death. And with that being said, I want you to understand that these devices do not see through objects. Webb, would you like to tell me exactly the average lithium-ion battery in a car? How well is that insulated, sir?
So it varies from manufacturer, but there could be multiple layers. I mean, you in most batteries now in the state that they've improved the architecture, you may have 3 to 4 layers of materials to get to the actual packet cells or pouch cells or cylindrical cells of the base of the battery. A large battery pack is not one big battery cell. It is hundreds or thousands or tens of thousands of smaller items inside to make one big thing that makes big power. So when you're thinking about what you may encounter in any situation, today we're going to talk about EVs, but if you're talking about in a handheld drill battery or in an RC car battery or in home battery in your storage systems, commercial battery in your storage systems, there's going to be multiple layers, and this is for protection of the battery. This is for heat efficiency. This is for cooling efficiency. This is for the organization and replacement should portions of the battery or the module go bad. There's lots of reasons, and the architecture can be everything from aluminum, steel, heavier brittle metals. You can have plastics. You can have insulating material. You can have low to medium expansion foams. You can have gels, and you can have some liquid cooling that can get in the way of what you may see. So think about it like this. If we looked at the outside of a house that is on fire, so a lot of what you discussed in the past, and you're scanning for size up, you may not see the heat signatures, but in small areas with less insulation. That's the same premise with a car with an EV battery. It's just in a different size package and a different shape. The problem on the inside still as dynamic as it would have been if it was on the outside. We just won't be able to see that a lot of times with the thermal imager unless it has gotten to a point where it is in runaway or it is showing itself with other things. And even in some of the videos and pictures that we show later, what you see on the thermal imager or the thermal imaging videos and pictures that we've taken in the burns, some of the burns that we conducted, is drastically different than what the visual the regular optical video is, because in the clouds that we find and that are created by these, and the gas clouds and the things, ultra fine particles, ultra and submicron particles compared to the 7 to 14 microns that you're discussing here. What you see is just massive amounts, hundreds of cubic feet per second or per minute of different types of chemicals coming out of these batteries that we won't see on the camera, but you scan up and you see very extreme heat signatures, but you pull it away and you look and you just see this big cloud. You know, you have to manage both and understand about how these are built, and then put all of that information together. This is a very dynamic scene in a small package. So I say small package. You know, a small package in the large vehicles, 10,000 pound batteries. In the a small package or a large package in the passenger car, 1,900 to 1,500 pound batteries, maybe a little bit bigger than that, depending on the size of the vehicle. But if you think about what it takes to get inside of that battery, what it takes to see what's going on, it's going to be the overall scene characteristics, again, not some specific spot that you're looking at.
Thank you. That's well said. And with that saying, we want people to understand that we don't want you to not use these devices, but we want you to understand what they will not do, which is in this picture here, you see a 97-degree measurement down this hallway. We clearly see greater heat than that. But there are many things that can cause the camera to measure even the heat inaccurately, such as the shiny surfaces. And Webb, how many batteries do you know of on EVs have skid plates or shiny plates on the bottom of it? Is that still a common thing occurring as well?
Yeah, pretty much everything's going to have some sort of bulkhead plate, because they are the outside of the vehicle in most cases. Okay. The ones that you'll see in the base of the battery pan is the base skid plate of the vehicle. Now they're extruded and built aluminum, so there's multiple layers, but in different cases, different architectures. And when I say architecture, the layering, the separation, the materials that's being used, when we say things like that, that's what we're talking about. So we're talking about plastic dividers versus aluminum dividers versus steel dividers. You can, I mean, in some cars, the battery separators are stainless steel sheet metal, formed sheet metal. Some is plastic separators. Some is aluminum dams that look like little pyramids that separate the batteries, the battery propulsion modules. And then the outer casings can be multiple layers. Like I said before, it's a myriad of information. There's so many places online to learn about this, and the best places is some of the best places to learn about what we'll see in the worst situation is for the people that work on and repair these things in the automobile industry. A lot of what I've learned has come from that. But when you talk about the materials, it's all going to have to, especially in the areas that it will be, it's got to be pretty. If you have this big, ugly utilitarian thing, consumers won't buy it. So it's going to have to meet what the vehicle looks like. These vehicles looks like stuff from the future. When I was a kid, everything looked like space shuttles. Now cars are moving to that direction. So when what you see on these, you'll have lots of very highly reflected surfaces that are just going to give you a false sense of security if you don't see or you're interpreting information properly.
Well, and that's one of the things I wanted to ask you about, because I've read some training manuals from various organizations stating firefighters to crawl underneath this or lift the car and point the camera at the battery, which to me is extremely inaccurate and dangerous to do so. Whereas from the videos you've shared with me, you don't want to be that close. And what's your thoughts on that?
So my thoughts on that is how science is performed for the gathering information way higher level than what we're doing, right? So when you go to a laboratory at Underwriters Lab, for example, Fire Service Research Institute and the Fire Protection Research Foundation are conducting a suppression project at this time. It's an ongoing project. There's a lot of really cool things. For them to measure the heat signature and the information around this battery, they have to put thermocouples in the battery case to actually see what's happening. If you point a thermal imager and try to get a surface temperature on something that has at least 2 to 3 layers, it would have to be so hot and so thermally conductive on the other side to give you a signature there that you've destroyed the other half of that battery because of what's left. It doesn't take much. Think about how much it takes, and Cars aren't built like they used to, but think about how much it takes to melt an aluminum can.
Yes,
And
sir.
you can melt, I can burn a hole in one side of the aluminum can, can't see the heat until I get the flame to the other side of the can, but the fire was still intense on the other side, no matter what I did. If you think about these battery cases in the same light, what type of energy source does it take for me to actually see what's going on if it is whatever thermal conductivity rating for the metal or the materials that are there, and how much energy has to be transferred, spread out, conducted through, radiated to the other side for us to actually see that? We're way too far in the game. At that point, we're not getting good information, and we're not doing something that is progressive. That's a very reactive stance. Reactive puts you in a bad situation a lot of times. We need to stay on the proactive side of this thing to keep it from the most dynamic situation that it might be, because that's going to endanger us, our equipment, citizens, another vehicle, you name it. It just makes the situation worse.
Well, and that's another thing is that these vapor clouds that come off, as you talked about, we're not going to be able to detect them with a camera, but these vapor clouds are extremely flammable and somewhat, in many cases, explosive. So I'm carrying, all fire service ticks are required to be non-incendive, but they're not ATEX certified or explosion proof. You know, that's another issue, is that we're walking up with our smartwatch on, our iPhone in our pocket, and not thinking twice about it. That vapor cloud is extremely dangerous, and that could also cause an ignition. So we don't need to do that. And that what you mentioned earlier, I wanted to ask, the battery itself is almost like thinking about ultra strength high or ultra high strength alloys. You got layer upon layer upon layer to make it stronger. So this R value of this battery of resistance to heat loss is extremely high. So it's designed to protect it, insulate it, cool it, as you said. So by the time we see it, we're looking at an extremely late sign. So how close would you want to be when you see it? Based on your videos, you don't want to be too close, because you're going to become part, as my dad said, you're going to be fuel. Don't be fuel, right? So
don't become part of the problem. Yeah. So
right.
the distance is your friend, and so there's a few things to think about. What we're looking at, and this continuous size up idea, the continuous size up. Anytime I think about a vehicle fire now, because of the prominence of electric or hybrid vehicles, there's more of them around. A couple years ago, we were talking tens of thousands, 50,000, 100,000 cars in the nation. You know, it was a slow burn at the beginning, and then as time has moved on, the market saturation of these vehicles has come to the point that if I go to a car fire, it's an EV fire until I prove it not. And then I have to gather other information and be more diligent about what I'm looking for, because the tactics sort of overlap, but then they absolutely go different directions when you, in my opinion, when you find out that you have an EV. And then what you're looking for, what's that?
Yes, sir. How many EV vehicles do you think are currently on the road in the U.S. estimated?
I have no idea at this point. I mean, when I was looking at numbers a few years ago, it was between 40 and 60% of the EVs were in California because of the market saturation and the production there. And I don't know what it is now, but I'm seeing what the economic side of this growth has become.
Yes, sir.
It's everywhere. I mean, think about it like this: when we were kids, we played punch bug. Now play that with Teslas or electric cars and see what's out there.
There you go.
And
red Tesla, no punch back. Yeah, I got
I know,
you.
right? So there's what it used to be. Man, that was really cool. I saw an electric car. Now there's 5 in a row. And when will we have the problem? It's not if you're going to have a problem. I stumbled into this thermal imaging and this lithium battery conversation at a garage fire in July when I was in the southern part of Gwinnett County at an engine company assignment.
Okay.
It started with small batteries and grew into, this is a much bigger problem. And our county had a much larger fire that was a large number of medium-sized batteries that went on for days because of how the batteries propagated themselves. And our hazmat company learned a ton, but it also put us in the fact, in the understanding, and my understanding as well. I've got a long way to go with this, and there's a lot of information that we need to gather We can't just run this like we have every other fire, because what we need to learn, what we need to see, what we need to take in as our size up and our understanding of the fires is drastically different. And I say drastically different. When you're looking for the same benchmarks, but the time in which that information has to pass through my brain and make a decision has been compacted down to 20% of the time of what I used to have, because of how fast these situations change in relation to how fast a standard car fire would have changed, or a room and contents fire would have changed. I don't have that time. You have to pick up cues and understand these things and have these in the back of your mind ready to pull out at a much shorter time period than in before.
What do you think the average temperature of one single cell pops? What kind of temperature does it generate on a lithium-ion battery?
So if I don't know the megawatt energy, the kilowatt megawatt energy, but
Yes,
when you talk about the thermal reading, it can be north of 1,000. It can be north of 1,000 degrees immediately. It doesn't have to ramp up to that. The exothermic reaction is instantaneous for the materials inside of these batteries, and all you need to do is damage the separator, expose it to air, a little bit of moisture, and you're off to the races.
I'd read somewhere that once that tab pops, it went to 0 to 1,000 degrees in approximately 1 second. Based on what I've seen you do, it seemed faster. Yes, sir.
Sometimes they can be. I mean, and again, that's going to depend on the energy rating of the battery, the state of charge. You know, what are the other factors? Charging cycle times. There's a lot of things, and the one thing that I've learned, and burning in the last since November, we've burnt seven full EVs, and I burnt a number of small batteries, a lot of batteries before this. I have video of just about every single one of them, and I can barely make 2 match, even if they're all the same batteries, because there's always going to be something different about how the fire propagates, how the reaction happens. But at the same time, tactics have been laid over to be successful, although it may look a little different, and you have to be very, very diligent on picking up the cues. Even to the point of, if you're not sure what this is, have somebody jump on a smartphone and look up the vehicle in one of the I use EV Rescue and every single time, and it gives you information. Or, hey, this is a Kia, or this is a Hyundai, or this is a Ford, or this is a BMW, or this is a Mercedes.
Yes,
Mercedes electric battery. Awesome. I need to know what this thing looks like, because that's how we're going to get to suppress the fire. This indirect cooling thing, you know, I proved it to my guys at work one day. I said, okay, guys, I'm gonna set a fire in this bucket. It's a metal salvage pail, and I'm gonna force it inside of a column of water, and we're gonna put this fire out, indirect cooling. And they said, no, we're not. I said, well, we keep telling the fire service that's what we're gonna do, and we keep telling everybody this is gonna work. And 50,000, 10,000, 8,000, 5,000 gallons later, we're still indirect cooling these things for the same reason our thermal imager is not going to work. How is that going to work? And in doing this, we unscientifically proved indirect cooling to be lackluster. There's other ways.
If you add a lot of water, you are also creating more of a vapor cloud in some cases, where you spread some of that around. Yeah, absolutely.
I mean, if we're talking massive amount, you're talking explosive, massive amounts of hydrogen fluoride, organic acids, VOCs, SVOCs, a ton of fluorinated substances. We worry about PFAS in this country, in the fire service, and in groundwater. My gosh.
Yes, sir.
The amount that's coming out of these, the amount of fluorinated substances coming out of these batteries when they go into a sustained exothermic reaction, thermal runaway, is astronomical compared to anything that we've measured in the time that it takes for these batteries to combust. We worry about PFAS and house fires and structural smoke. We should worry about fluorinated substances in these. What are we doing about it now? It's the compounding situation of continuously making slurry. Submerge a car in a big dumpster roll off. We've now just made 20,000 gallons or 10,000 gallons of slurry that you have to put in a drum, send somewhere, and have them remediate that. What did we do to make the situation better? Oh, we put the fire out, but we watched it burn inside that water for an hour. The gases, some of them are miscible in water. Not all of them are miscible in water, but some of them change in water to create a new compound, and now that compound in water is more hazardous than the initial compound. And we're still releasing some of the same gases in the atmosphere, and you have the ability to breathe that in, and you're going to absorb it through your skin and mucous membranes.
Oh.
We're not good. That's not the right thing.
Well, and the reason I wanted to ask you all that about the measurement aspect of it is NFPA removed the spot temperature from thermal imaging cameras in 2021. The new standards coming out this year is 1930 instead of 1801. But one reason they did that was due to 3 line of duty deaths that it was cited as a contributing factor. And one of the things I wanted to get your input on is this incident in Surprise, Arizona, where they used the thermal imaging camera as a thermometer. And, you know, there's some signs in this, but what's your thoughts on this as far as what occurred, and what feedback could you give the end users of approaching an incident like this, like approaching any type of lithium-ion incident?
This is a really terrible situation. I can't imagine having to deal with a situation like this in my own department.
Yes, sir.
The difficulty in something this size, this picture doesn't do this justice.
Oh, you're right.
All right, take for example what was going on in Monterey, California, maybe a couple weeks, 2-3 weeks ago now. Those battery modules, those super packs, mega packs, were in the neighborhood of 80,000 pounds a piece.
Wow.
That's roughly the size of a 40-foot Connex box. Give or take the dimensions for conversation. Looking for things here. What are the other signs? Not just the thermal imaging. Let's start with the packet. Then if these are packet cells, there's a small cell the size of your hand, or maybe the size of a legal pad. They're and then they're stacked into a smaller box, and then that box is put into another box to make a larger module, and then those are stacked in shelves with cooling systems, high voltage electrical controls, possibly a suppression system. There's a suppression system that goes in these containers. And then we're asking the fire service with limited knowledge to deal with an alarm or a smell of smoke or an odor or whatever the case is. And this is what it looks like before it deflagrates and blows them with the door into a fence some yards away.
75 feet. Yeah.
What's, you know, what can we find? You know, we're looking for pressure in small openings. We're odd odors. These batteries have this very odd, sweet, pungent chemical odor that comes off. You know, a long time ago when I was taking a hazmat class, they said, if you smell this, cyanide. And I'm like, oh God, I don't ever want to smell cyanide. I'm scared to death of this.
You smell burnt almonds. Run away.
I know, right?
Yeah.
So seriously, so here, this is kind of the same thing. And the off gassing that comes from this, you know, they won't know this, but they probably could have sensed hydrogen. I haven't come across a monitor that can sense some of the gases to the level that you probably have to, that's handheld, portable, be on an engine company, hazmat company, truck company, things of that nature. But the smaller things that you have to kind of look at, a 360 of a building that holds batteries, knowing that going in, trying to find out more, if this is in your response here, find out more about how they manage it. You know the scary part of these things? They are built with blowout doors.
Yes, sir.
If a case of something is built to manage pressure, overpressurization, it's immediately a red flag that we have to do a lot more size up, a much more in-depth due diligence research about what we're getting ourselves into because of how they engineered safety mechanisms into a machine that could kill us.
And it's not
You know?
a standard house fire, and that's why we should
Oh,
stop.
never will be.
And we need to quit approaching as such. So, but the lack of training in one device and the lack of education in these, as you said, they're being forced to respond to it. Fire departments across the nation is not at fault. They're being, this is outpacing our knowledge and our training, and basically guys and gals are going to get injured and killed if they're not careful. In this case, 3 were not killed, thankfully,
Yeah.
but they were knocked unconscious and injured. By the grace of God, they were not. So.
Well, and this is going to happen. Man-made things fail. These systems, it's not just that I ran one of these years ago at a server farm in Gwinnett, and the company called them geopods. It was about the size of a Conex box, had blade storage for batteries, melted a couple of them off, suppression system, did a little bit about what it did. Didn't know a whole lot about it. 8 or 10 years ago, it was not as prevalent as it is now. But that was a backup system to the electrical grid for a server building, server warehouse. And these things are around. Photovoltaic systems have these, and it may just look like a control house. Yes. At a solar farm. Mm-hmm. Probably has a large amount of batteries inside. Mm-hmm. And so back up to this. Why are we just focusing on this as the industrial? These are in the wall of garages and homes as battery backup systems from Home Depot.
Yes, sir.
You can buy Generac, you can buy the Tesla wall systems. There's a ton of them out there. Same thing, different scale, same problem. There's a video of a battery deflagration that blew a small garage door off next to a captain on a walk around.
Yeah, I've seen it. Yes, sir.
That the gases come out in the explosive, between the explosive limits. They're ready to go. They need an ignition source. Sometimes the ignition source is heating. Sometimes the ignition source is static. Sometimes the ignition source is us.
Yeah, sadly.
Sadly.
So with your knowledge on that, as we get into your expertise of suppressing this, let's start with something small. So we talked about something big. This is correct me if I'm wrong, this is you experimenting with a laptop, correct?
It's a small packet battery that would be used for a laptop. Yeah.
Okay. Packet battery. Okay.
Mm-hmm. Yep.
How easy would it be to extinguish this? But how dangerous is this? What would be your input before we move into the vehicle fire side of this?
So scale is everything. If you're exposed to a battery fire, or if you're going to a battery fire, is it one small cell, or is it a lot of cells, or is it huge packs? First thing, small, medium, large. What's the problem, right? There is heat coming from this. All this was a small damage. We poked a small hole in it with a brad nail and burned and burned a battery. It's only like this big, right? And with what comes off of this, again, you're seeing the heat signature. There was a cloud that you couldn't see this on the ground. Uh-huh. We're talking about a battery twice as thick as your cell phone, about as big as your cell phone. Mm. And it made enough smoke that it would fill up a garage. Wow. And I say smoke, exhaust gas cloud, if we want to be technical, yes. Right? Yes. So everything coming off of this is dangerous. Dangerous levels of chemical exposure, respiratory hazard, skin contact hazard. It is acidic. It is high concentrations of carcinogenic things. Yes, sir. And it will do this and stay hot and produce its own heat for minutes or hours. If you want to cool this off, you can throw it in water. But it will continue to do this in the water column. If there's nothing to inhibit the chemical reaction, it will continue to combust in the water column. It is water reactive. Now, it's not water reactive like the old 3rd grade experiment with sodium in water, which was awesome, right? My first exposure to things blowing up in fire. So like, blew my mind, wanted to know more. So when you get into the battery conversations, you know, there's a video in Lake County, Florida. There's a gull-wing Tesla burning underwater for an hour.
Yes, sir.
Salt water's worse. So when you want to stop this, you have to have something to cool it, absorb the energy fast enough, right? And stop the reaction.
Well,
It's
the
very
complacency
difficult to stop the reaction and see. So, and the other thing about it is, where is this going to be?
Okay.
Is it charging on a shelf? Is it in a device? Is it next to another battery? Is it going to coat everything in a room and then light off, and then the room's growth progression in the bell curve of up to fully developed? It didn't start here, it jumped halfway up and then started there. You know, we've accelerated everything that we have changed about fire dynamics and understanding fire behavior with spray painting the inside of a room with chemicals with some of these batteries if they're in homes. The UL videos prove this. The FDNY work proves this. The FDNY's numerous amounts of fires that they run. And it's not just them. That's a densely populated area, so we see it. They're all over the country, all over the world. But it's not just what it is and what it takes. I learned about this. We were overhauling a garage fire. Why is the garage continuously burning? We thought that the truck was burning ethanol because it was in relationship to there because the workbench fell over. It had nothing to do with that. We found out that it was an exorbitant amount of drill motor batteries for power tools that we had to take out and put in a drum outside, and they still bubbled. I've had batteries in water baths for 4 days, this big, still releasing hydrogen, where you could take a torch and light the bubble of hydrogen as it pops out of the water.
Wow.
The reaction will happen until it exhausts the battery cell.
But just that small battery cell, since you mentioned it before we get into you talking about your experience with cars, I was talking to another EV guy recently, and he was sharing where a 9-year-old girl went to the hospital and they thought she had been vaping, only to find out she had been exposed to a small amount of smoke from hoverboard fire, and it permanently damaged her lungs. So if a firefighter approaches seeing a small amount of fire, and all of us being honest, being complacent, have our stuff on, but not have our face piece on, that small battery could cause severe damage to someone's lungs. Yes or no?
Yes. So years ago, when the 16 life safety initiatives came out, the second year that they were out, there was a video of a firefighter. I don't remember where he was from. He remembered, and this was his account in the video, he remembered 3 breaths before he was unconscious, and he is permanently disabled, still alive, thank God, permanently disabled because of what he inhaled at a standard internal combustion engine car fire. Whatever it was, no idea. But whatever the concentration and the quality of the chemicals, it's hazmat. Dose over time or one strong dose, which is it going to be? This is one strong dose. This is a very high quality chemical dose. So when you think about the small battery versus the big battery, this vehicle fire that we're going to look at, there is 32 partial modules, and inside of the inside of each partial module, I think there's in the range of about 20 or so, maybe a little bit more than that, packets. And the packets are about this big and about yay thick. So when you think about that, one packet, like I said, that small battery that I burned to show you, the laptop battery.
Yes, sir.
That put enough smoke that you couldn't see the concrete and where we set the battery on fire. And all we did was poke it with a small brad nail.
Wow. So when we talk about exponentially, now we're looking at a car. I want you to take over and just go where you want to go. I'll control the videos for you.
Yep.
Walk us through what we see here, what your thoughts are on size up and fire attack considerations as we move through this, because to me, firefighters run car fires every day, but now they're dealing with this incident and how this changes the game, level of protection, exposure hazard, what they need to do, all the things that you've learned. Share with us as I'll start the video. You can just go to town, feel free,
Okay.
let me know what you need. I'll be here to help you.
Yeah. So first of all, this is a Kia EV6. This was a brand new car. It had 36 miles on it. This was the second charge cycle ever. 100% charge on this car. And what you can't see is in the regular video, you can't see the side of this car for the amount of smoke coming out of this vehicle. It's just a big white vapor cloud. And what you saw there was the corner of the battery blew out, and there's fire. There's fire inside the car, and the fire is propagating inside the battery case. Inside this battery case, the architecture, aluminum outer, aluminum dividers, plastic cases, plastic dividers. So it's got a lot of room to run and a lot of very flammable things inside, and all the packets are foil packets that just look like wrapped up tin foil with the edges that are taped with aluminum tape. So in a moment, you'll see this fire progress and grow a little more. But what do we see? We see nothing on the thermal imaging camera. The Surprise, Arizona, saw nothing on the thermal imaging camera to speak of. If I was just scanning this and I see, oh, it's just a little bit of white smoke, it's not a big deal. White smoke in the structural environment is not a big deal. White's very concentrated, dense white cloud of smoke in this environment is explosive. In a video later, you'll see the flash and the deflagration of the battery taking off. But what's happening is the battery case is heating. We perform mechanical damage. We poked a hole in the battery for the sake of time. You can overcharge these. You can overheat them. You can do mechanical damage. All you have to do is damage the separators, arc fault inside the battery, one of those things, and you will create thermal runaway. This battery, the mass of the battery is in excess of about 12 to 1,300 pounds. So you think about the mass of the vehicle versus the mass of the battery. Most of the vehicle is there. Superheated gases come out as we open the door just to see fire propagation, to show them what's going on. Now there is a large amount of smoke coming out, and you can see where the damage of the battery was in the rocker panel of the vehicle there. As it grows, it's going to continue to progress. In a moment, you'll see a lot of spalling and a lot of chemicals boiling out of the battery and spraying all over the area outside of the door. And you know, right here as it starts to grow, we went from that to this in approximately 6 seconds. So the fire progression, if we had opened the door and there was a spark or an ignition source, that cloud lights off, we're in a dangerous area that could kill us because of the immediate fire progression and immediate explosive nature. Now we're using a 45-gallon-a-minute nozzle, right? It doesn't take much. The point of what we do with low-flow nozzles is it doesn't take much if you do it properly. Now, if you notice all the material coming out, the little white hot and dark pieces that are coming out, all that is the material inside the battery boiling out of the battery and expelling out of the damaged area. You know, these are abnormal things to see. Do we normally see vehicle fires boil? We don't see vehicle fires boil, right? If we're trying to say, is it battery involvement? If you'll notice underneath the rocker panel, there is an excessive high pressure fire vents pushing out under the bottom where the seams of the battery are. That again is fairly abnormal with the intensity and the growth. So could there be fire under a regular vehicle? Yes. Is the fire going to progress as rapidly as it did there? The direction of the fire, the pressure of the fire, the intensity, the time that it grew? No. The things that we see here, and it doesn't take much. What you don't see after this, and this is a cut up video, but what you don't see after this is we had this fire contained and out in 6 minutes, and we used less than 500 gallons of water with a product called FCLX. So
that's
when
what I was
you're
going to point
doing,
out, this is not just traditional water though.
No. We use FCLX and water, and it's just on tank. But when you look at a different vehicle, this is the Kia EV9, and something I will note. So what we're looking at as far as the intensity of the fire, the heat, the thermal plume moving through where the fire location is. What you can't see in this and what you can see in real life is the quality of the flame. The quality of the flame. So if compare a piece of clean wood, the flame intensity, the color, the way that it propagates, the way that the smoke moves, and then burn a piece of plastic. The density and the lack of opacity in a piece of plastic because of the rich amount of fuels that are there. That's what we normally see with vehicle fires and synthetics in houses and things like that. What you're going to see with these type of fires is a light pink, fairly translucent flame. Gas-fed fire, and I say gas-fed fire, it's when the batteries cook off and they boil and expel these gases from the exhaust ports. We're immediately burning the state of matter that burns the best without having to do much, expel much energy to create that fire. And what we see is that. But what you see in real life is a lot of light smoke. All right, a lot of light smoke, which is very high concentrated, high intensity, chemical laden smoke in that column, and you see very intense flames. But the flames don't propagate the same way that you would if you burned a tire, if you burned wood, if you burned things in a house, or if you burned a regular car interior. When you look at things for size up, you know, there's in the beginning of this, the fire smoking off, you see it pushing out of the battery, and then there is a flash, right? And I think we have it in the next slide. You can go to the next one.
Got it. I hit the wrong button. There we go. This one or next one.
No, I guess we pulled it. It's okay. But in the beginning of this, it goes from a small flame. In the beginning of that vehicle, it goes from a small flame out under the rocker panel, right in front of the rear wheel. And then the gases light off because the amount of collected heat energy ignites the gas cloud. There was no fire. There was nothing but other than smoke production.
Yes, sir.
So what you might see coming up is high pressure vents that look like steam. It is dense like high quality steam. It's not going to be until it moves into the flaming production phase like it is here. You're not going to see dark, dense smoke. Once it gets to this point, you will, because it's going to start combusting other things. But the rapid growth, sir.
I said the key that you with suppression though is you identifying that and trying to get it into the area where the battery is exposed. Is that correct?
Absolutely. So if you'll notice under the wheels, and there's some pictures later we'll show you of this battery pack actually, what it looked like before the fire and what it looked like after the fire.
Yes, sir.
You can put water into vents. How do we find vents? Well, we can find vents by looking at the response guide. And some of the response guides show you where vents are. Some of the response guides tell you to put water in certain places. Some of the Kia response guides tell you to put water in battery openings or battery vents to help cool the propagation of the fire inside the battery case. Some say don't do that. You may make more fire. Well, if it's on fire, my opinion is put the fire out, right? If we make more fire, or if we don't do this and we let it go, you know. Before we get into the phase of the fire, there's one thing I wanted to throw out. You know, yes, I've told you, sir.
No, go ahead. I'm sorry.
I've said already that, you know, we've put these fires out with 500 gallons or less in 5 to 15 minutes. There's count them on the internet. The suggestion of a lot of suppression guides right now says between 2 to 5,000, 5 to 8,000, 5 to 50,000, 5 to 10,000. The ranges are all over the place. I think everybody's throwing stuff at the wall and seeing what sticks. But if you put the water or your suppressing agent, whatever you're using, in the right place, and you manage your attack strategies and tactics properly, then you're going to save battery. You're going to put it out before the rest of it goes. Now, you may be asking, why do you want to save battery? Well, we want to make the fire better than it is now. We want to take that timetable and move it backwards. So we want to stop the propagation. We want things to go. My counter to that is, if it's going to take 2,000 gallons of water, I've never seen an engine. I've seen tenders and tankers that have 2,000 gallons of water. By the way, I say tenders and tankers. If you're wildfire, don't give me a hard time, because ones have wings and the other ones don't. I get it, right? So, but if you're looking at engine companies, what engine company carries 2,000 gallons of water? Are you in a place, is this going to happen on the interstate where there is no water supply? What's the further repercussions of, man, it's going to take us 6 hours to put this car out? The optics of a fire department not being able to put a fire out, to me, is appalling. But the optics of everything else that surrounds the time that it takes to flow 2,000 gallons a minute out of a hand line, 5,000 gallons a minute, 8,000 gallons a minute. I've heard as much as 50,000 gallons for one car fire. Now, my counter is, the time that it took to flow that much water, the battery consumed itself and the fire went out in spite of what the fire department may have been done, albeit well intended. So in that respect, I think there is a better way to look at this in phases. And a few of us have traveled, and we're trying to pass education, pass on knowledge, things that we've learned, ask a lot of questions everywhere we go. What have you done? What have you heard? What have you learned? I just want to be a sponge and try to figure these things out. I've just been lucky enough to be in the right circles, in the right places at the right times, to have the opportunities to do these kind of things. But if you think about it in phases, so phase one, standard fire tech, we are assuming this is an EV until we're proven otherwise, right? This thing is guilty of being an EV until it's not, because the EV is going to be the most difficult thing we have to deal with. Even if you're talking about other alternative fuel vehicles, if you're talking about hydrogen vehicles, if you're talking about ethanols that are complicated, but we have really solid ways to deal with those things. The EV side, the technology has well surpassed our capabilities in the fire service to be able to knock this out confidently. Not competently, because we can do that in the fire industry. Confidently. I think the issues in the industry is the confidence of what we can do, because we're just not sure about this fire because we don't know enough about it yet. It's still in the infancy of our learning. The research projects, my God, they're still ongoing. I'm part of two projects, one here in the Southeast, and one I'm participating with one at Iowa State University as well. The one here with NC State, Illinois Fire Service Institute, the Fire Protection Research Foundation, and we're studying chemicals, and we're burning small scale, bench scale, what they call bench scale fires, and then medium scale, light mobility, and then large scale, full scale vehicles. So we're trying to learn a bit about this. That's two projects. There's a suppression project going on. There's a couple other projects at other universities happening. There's very few. If you research actual papers that give you information about this in the world, there's not that many that are out there. There's a lot of things out there that have done data linkage and peer review studies on the papers that were written, but there's very little information in the scheme of the fire service in the world to draw from. There's more daily, but but we're behind the eight ball. So how do we do this? The phase of fire attack. Our standard engine company operations is where we need to hold ourselves accountable. So if we look at what we're doing, right? If we go out, a standard engine company with the amount of people that are going to be on the standard engine company, you'll see in all our pictures and videos, it is a one person, one line, with usually it's me and one other person. One of us has the nozzle and the other one has the thermal imager. That is how we operate and put these fires out. We want to show people that it doesn't take an army to put out a vehicle if you are competent and confident in what you can do. So if you do find that it's an EV, we need to make sure that we're looking for openings, looking for access. So if we just fight this like we have always done it, hit the tires, hit the ground around, work, focus on where the fire's coming from. The fire's coming from the battery case. Yes, you can put out the seats and the furnishings on the inside, but the fire's coming from the battery case. And just cranking it up, lifting it up so you can squirt under the bottom. If you want to squirt under the bottom and that's what your fire department is comfortable doing, understand that there's an expectation to meet there. But if you take the nozzle, even at a low flow, and direct it to the vents, direct it to the openings, direct it to the pressure exhaust ports of where these things are coming out of the batteries, you will find success. Use the thermal imager, find where you're there, and then align what you see without the tick and what you see with the tick, and then direct your efforts there. We don't just flow, open the nozzle and flow until everything goes away. We'll knock down a crowd of fire, step back, look, see what changes, go to that spot. Knock down a crowd of fire, stop, see what changes, go to another spot. And then we'll continue to move in that direction. That's been very successful for us, but that's our phase one.
You mean that's not scream and shout and spray water all about? That's not how we should do it.
Don't necessarily have to do that to be successful. The fire, listen,
Okay.
Chief Brunasetti said it a long time ago, we can do a lot of things, but sometimes the fire goes out in spite of everything that we do.
That's right. Amen. God bless.
So phase two, if you need to buy time, if you need to isolate, if you need to give yourself a little bit of breathing room to set up another operation or to expand into a different tactic or strategy, isolation or removal is a good idea. All right. It's not going to put the fire out at all. It may slow it down. It may stifle it. Depending on the quality of the fire blanket, it may last and it may not. Blankets have thermal ratings. It's about the thickness and what they're made of. I've seen up to 50 hours if you wet them, down to 30 hours if you don't wet them. Every one of them is different. They're all different materials. Some are just woven. Some are this rubbery heavy membrane with that coats a woven material. That there's every make and model. They do have a place, but they are not the end all be all. I will tell you this: if you're going to employ any of these tactics in your department, understand that the monetary impact of what you're doing is substantial. If you take an 80-pound blanket, 20 by 30 piece of material, and cover up a vehicle, you have now thrown that away and have to figure out how to recoup the cost. The same with anything. And if you ruin your protective clothing, if you damage your SCBA, all of this is a different mindset. If we have to isolate this, and this is what you're doing, you still have to monitor the rate of rise, right? How fast is the thermal environment changing tells us about what the battery is doing. It's not just, oh man, it's still 500 degrees. It could be 500 degrees 8 hours from now. Is it ramping up over a tiny piece of time, or is it slowly growing? That's going to tell you about what's burning or if there's still energy. The one thing about battery fires is there has to be electricity, there has to be energy for it to be the flamboyant thing, the most extravagant fires that we've seen in the videos. If there's no energy, it will burn. Don't get me wrong, it will burn. The things are still bad, but it's a very lazy, slow-growing fire most of the time. So understanding that it has to do with the energy. That's why I told you in the very beginning, that car, 2 charges, 100% charge, and the mass of the battery, it's a pretty good fire. Yeah. Same thing what they were doing here in this one. They were burning an EV and then showing that they could stop suppression activities to cover it, to give time, to buy time. These do not stop fire progression. You have to understand that this is not how you put a fire out.
Since you mentioned that,
there was a fire in Charlotte recently. Oh yeah, and you have an EV blanket video. But there was a fire in Charlotte a couple days or a day or two ago in a parking garage, and to get everything in place, is that a place for a blanket? It has to do with access. If you can't get it around it or you're trying to isolate it, it's just another way. Think about houses, right? We have to relate everything to what the fire service understands. We don't need to recreate everything and reinvent the wheel here, right? If we can take a fire and put it in a compartment, can we control the fire in the compartment? We are good at that. The American Fire Service can put things out in boxes because we fight house fires every day. If you take this and compartmentalize it, you can fight the fire. Compartmentalize it in the battery case. Compartmentalize it in the passenger compartment. Compartmentalize it because of time or whatever the outside influence is with a blanket. And then you have to still fight the fire, but it gave you time to set things up if that's what you have to do. It's just another way to go about it. But seeing what you may see, This thing that you see here, that thermal signature, will destroy that blanket, and the blanket does nothing for you, possibly in a short period of time, depending on how you manage that situation. Water still helps, still have to have thermal absorption rate of water. If you can improve the thermal absorption rate of water, do it. That's why we use FCLX in our burns. But when we're looking at things like this, or you're in researching these kind of things for the suppression capabilities of your department, understand that you're getting into some really complicated scenarios that one thing's not going to solve the problem for all the things that you may run into. You can't say, man, I tell you what, our city, we're really proud of this $3,000 or $4,000 thermal blanket. Well, it's going to put the fire out. Well, not really, but it slows it down. And if we don't do anything, it's going to burn for a while. But if we do, there's the rest of the story to have the conversation. And then, to me, all this stuff has to fit together. What's your training look like? How are you applying thermal imaging? How are you using continuous size up? What are you doing to protect the other things that are exposures? By the way, exposures are people. I'm helping set up a burn right now, and the worry is that they're too close to an area where there is a restaurant and an urgent care and et cetera, et cetera, et cetera. If this fire happens in a parking lot in front of the urgent care, are we going to just let these things burn? I've seen people that we just got to let it burn. We can't do anything else. How many more problems did we just create by letting that happen?
Agreed.
Not okay.
Agreed.
So in phase 3, specialized tactics, right? What are we going to employ that is not the run-of-the-mill engine company gets off, this is what they do every day, bread and butter idea, right? Engineered openings, access openings. Now look at this battery. The left picture is what it looked like before we destroyed it. This was under that. This was under that big car, the one that was the second video, the EV9. All right. This battery weighs about 1,400 pounds, and is 85 kilowatt hours, and it was fully charged. This is an aluminum case battery with reinforcements, and there is a plate that goes over the top and a pad that goes over top everything that's there. Now, inside of those boxes are the packets, and there's buffers in between each packet, and there's buffers in between each of those little black boxes. That's all the layers that you were talking about earlier. Are you going to be able to see through all of that with any thermal imager? Negative.
No, sir.
Are we going to get a good picture? No. Can you see other signs? Absolutely. Every case comes with vents. Every case comes with openings. If you look at the end of this thing, the orange spots on the end that are outside of the case, the orange piece, the orange pieces that are in the corners, anywhere where other items protrude the case, and on the top there are water resistant vents, and I say water resistant, right? They're not waterproof. If you saw the news of of one of the electric, I think it was a Tesla truck that went through a car wash and they put water in a bad spot or damaged the vent somehow and they caught on fire. Anytime there's a flood, you have a wide array of electric vehicle fires. They're susceptible to water. It is what it is. Creates arc faults. Heat can't dissipate. You name it. But also, what you need to notice inside of these things, you need to know about the architecture is there is cooling systems. The cooling systems can be ribbon tube that is run between there. It can be cooling heat sinks that are in between batteries. The Rivians have cooling plates in between the stacks of batteries. These have coolant lines that looks like this basically antifreeze that runs through tubes inside of there to help dissipate. There's going to be a pump for this. There's going to be a reservoir for this, just like you had a radiator for your internal combustion engine. There's a lot of systems that mimic what we have in regular vehicles in this as well, which you will also be able to see with some of the things coming out to help you identify different fire issues. You know, if you see, you can see hot liquid boiling out of something, or you see things pushing, you know, there are other signs that are indicative of electric battery vehicles, whether they're plug-in hybrids, battery EVs, long range hybrids, long range EVs, things like that. But then how are we getting access to this? You know, the pictures on the right, those are damaged areas where we put water to knock the fire down and get it under control, right? but access is still the enemy. There's lots of places here that are small openings. You look at the top picture, there's dark areas. The battery case opened itself, and because of the fire, and then we were able to put water there. But there are other ways. Why in some areas are they piercing battery cases and other areas not? Manual piercing nozzles. Is there a risk of shock? Is there a scare of electrical hazard? There's electrical hazard. This is a 500 to 700, maybe an 800 volt battery at 85, a max potential of 85 kilowatt hours, but each packet may be 13 volts and much less. But where is the danger? So we have to understand electricity. Also, there's automated systems and then high pressure cutting. You know, the high pressure cutting systems, the ones that you see overseas that are now making it to North America, give access to places where we couldn't put ourselves. Right. The Rosenbauer system's been around a while, and they use air pressure to drive a spike and then flood it with water. You know, that they all have had different measures of success. But what is the worry? You know, I've seen hazard statements in the manuals. Don't puncture the battery. You could cause a fire. There's a risk of electric shock. Well, AC power and DC power is different. The one thing that we need to understand about some of these specialized tactics has to do with understanding electricity and understanding what the potential of hazard is inside the battery. And then all of this is going to have to fall back to a risk-benefit analysis. So what is our gain from doing this, right? What's the situation? Let's put it back in front. Let's put it back in front of the in front of the row of businesses or the urgent care. You know, how long do we want this to progress, or do we want to put this? You know, I've got a friend of mine that works for Pfizer, and they don't want these anywhere near because they have lots of potential of dangerous things to happen. What about hospital situations? You know, how long are we going to do this? Now, understanding about the energy, you know, the AC versus the DC, we have to have a conversation about ground path. So ground path, the connection between the positive and the negative for the energy to discharge somewhere, right? There's also been questions about arc flash. For arc flash to happen, there has to be an arc gap. All right. If you're talking about an arc flash, think about what we've seen in the electrical industry with regards to large switch breakers and things like that for buildings, different phase power. That's can be very dangerous. There can be a large gap to create an arc. Have you ever seen some of the videos, the line workers working on that? Large gaps, large static fields, the large arc flashes, and they can be excess of 2,000–3,000 degrees, right? Now, if you're thinking about this here, the AC is seeking a ground. The AC power is alternating currents is seeking a ground. The ground contact is generally the person or whatever gets it back to Earth. All right, DC is different. The electricity is electricity, no matter how we look at it. It's a flow of electrons. All right, but if you're thinking about the DC power, what's the ground path? Have you ever been working on a vehicle or working on a lawnmower or something and sparked off a wrench on your battery? That's DC power. Now, if you took one finger and the other finger and put one post to the other, is it going to hurt you? Probably. Could it burn you? Yes. Can you take a wrench and touch both of those things and in the middle, it arc on the wrench on the left side and the right side and it not hurt you? Probably. We've been trying, and I'm going to continue to do it, to arc out these batteries and measure electrical flow. I haven't yet. Now, if you touch the positive and the negative connector of the high voltage cables, the big cabling in the center, the big orange cablings, the flat bars are just bus bar connectors, right? Okay. But if you touch those, or this big orange plug at the very end sticking out of the battery, there are two blade connectors that go into the battery. That if I took a piece of wire and connected one to the other, that is a good potential for me to hurt myself. But if you punctured or used openings to continue suppress, if there's a spark, you have a low potential, but the potential is there. All I'm saying is other options are available to us if we look at this in a technical mindset to figure out what we're dealing with, how are the dangers mitigated, and why are the warnings there? Some of the warnings in the response guide says don't puncture the battery, you can cause fire. Well, if we're responding to a fire, now what? You know, I just question those things, you know. But and the other part of this is with respect to education out in the fire service. What is the background of the message? I would ask instructors, if you're going to present information and say that you could absolutely never do this in the fire service, that's a really bold statement. To say that there is only one way, or that you can never ever do one thing in any situation, no matter what it is, those are two really bold statements in the fire service for the dynamic nature of what we do in our job.
True.
That's the same thing with the piercing nozzles and this mechanical. We've got to get the solution there. And then the chemical contaminants, you need to mitigate these. You have to deal with it. It's very acidic. It can damage. It can hurt you. It can damage your protective clothing. Decontamination. There's a lot of conversation about that. But the specialized tactics, to say that we can't go down this path, it's a bad idea. Everybody says you can't do it. I'm working with 2 vehicle manufacturers to do it.
Well, since you mentioned it, Webb, you say specialized tactics, would you also advocate that this level of phase of fire attack would be more of the highly trained individuals do this, not someone just figuring it out, correct?
Correct. The amount of due diligence it took to figure out where we wanted to set this battery on fire was hours and hours and hours of research and look and videos and manuals to figure out where things are, pictures of the inside, figuring out where the location was in the vehicle, just to pick the right spot to create mechanical damage. Outside of that, now we're working on general areas for fire suppression overhaul. In most battery cases, think about it, where do they want the most vital components to be protected? In the middle. Are they going to put the most delicate and highly energized thing on the outer edge of the vehicle where you have crumple and crush zones? I haven't found a single battery construction that has yet. The notion is that there are areas that we could do this safely. So when we get into thermal, yeah, absolutely. So when we get into the thermal imaging side, we have to compare what we're looking at. And earlier I talked about, do regular vehicles boil? This vehicle here is blowing liquid and melted contaminants out of the battery case and out of the car from a burn through vent. Now the battery case of this one and the battery case of the other one, they're both aluminum cases, and it doesn't take much to melt it. It takes little heat to go through it, so they're going to give you a pretty cool show pretty quickly. But if you look on the left, we did the damage ourselves. That's right on the edge of the rocker panel to create the fire, right? So is this possible going down the road? Absolutely. An electric car runs over a piece of metal on the interstate, pokes a hole in the battery. Same thing. How do we figure out where what we're going to see? What you don't see in the left picture is you can't see the door because of the white cloud. What I can see with the thermal imager is a highly pressurized vent. That's a highly pressurized exhaust vent about the size of a golf ball-ish.
So you're advocating using the TIC to basically guide your stream then, correct?
Absolutely. That is the way to do it.
Perfect.
So you could, even if you, let's say someone didn't have a TIC or one not available, or whatever the case is, you could still accomplish fire attack because visually you would be looking for higher pressure exhaust. The thermal imager makes us more efficient. It's a tool. It's a tool that makes us more efficient if we utilize it properly. And then it's not the spot temperature, it's the rate of rise. The difference in the picture on the left and the picture on the right, 30 seconds.
Mm-hmm.
So what you see on the right is the deflagration, the explosion of the gases that were being collected on the left. One spark, enough aggregated heat,
Mm-hmm.
and the picture on the right happens.
And the key to this too, I want people to understand that just because your camera reads 1,025 degrees does not mean that's what the temperature of that environment is. That's what the dynamic range of it is. You
Correct.
know that these temperatures could exceed, pushing 2,000 degrees in some cases. So
Very much
we
so.
want them to understand that these are qualitative devices, just allowing you, as you so eloquent said, guide your efforts and help find the problem when you have that vapor cloud or high heat.
Yeah, oh, absolutely. I mean, and we're taking in information for better decision making.
Mhm.
Better decision making creates better outcomes.
Agreed.
So as you do all of this, the
Mhm.
information, you're good. You're good. As you do all of this,
Yep.
it's the aggregation of information.
Mhm.
What are we taking the time to learn about EV fires, electrical battery energy storage systems, wherever you might find these? What are we doing to change our mindset about what our capabilities are? What are we doing to help drive our departments? What are we doing to help drive the training environment? What are we doing to help understand the research process? And what are we doing to understand the danger in the community? What's the hazard assessment of your community for these? Do you have these in parking decks? Do you have parking decks? Do you have high concentration areas? Are you near an airport? Some of the highest concentration of EVs that I've been able to learn about are at airports, because there's huge rental yards and there's electric vehicles that airports use, and you name it. They have more per capita, if you want to say that, of those things at some airports than you may find at any other place other than a place that makes electric vehicles.
Agreed. They have them daisy chained together, parked right next to each other in
Exactly.
massive storage areas. Yes, sir.
Good luck with that one. It's just like in the maritime industry. I don't
Mhm.
want to do that.
Yeah, China had 55 buses side by side. The one went right after another, burned them
Mhm.
all up. Yeah, very
And the
very good
batteries
example.
that they put in those, some of them are made in South Carolina.
Oh
17,
wow.
900 to 1,700 pound modules up to 10,000 pounds. They're everywhere. They're everywhere.
Well, in closing, with all the information shared, you've obviously put a lot of time and effort in this. This is just a small snippet of it. Where would you go for the people who are watching if they want to learn more and if they're just as fascinated by this and wanting to help their departments out or get more education? Where would you send them? Where would you start? If you started over, Webb, where would you go?
So start with emergency response guides.
Okay.
Start with blogs about, and I look at Firehouse, Fire Engineering, Fire Rescue One, Fire Apparatus, all the different trade journals that are out there. And NFPA, the NFPA website has all of the guides listed in one giant category. There's 700 or 800 of them at this point that you could run across in the United States. And that's just vehicles. That's not including all the other things that are out there. There are apps. I downloaded one the other day, EV Rescue, on my phone, and it gives you, you can type in, you can search, and it will let you see everything in the response guide. And the response guide is not just first responders; it has second responders and salvage, which is a whole nother conversation about what we may be getting ourselves into. The Fire Service Research Institute from UL, with their fire research, the Fire Protection Research Foundation under NFPA's research arm projects. There are FEMA projects. Homeland Security has a ton of resources on if you start searching for lithium battery response. TEEX has a huge project. University of Miami is working on. I mentioned the project with NC State, Illinois Fire Service Institute, and Iowa State University are working on some. There's some work out of Arizona. There is a ton of resources, and generally, if you want a good spirited conversation, just go argue with people on Facebook. If you really want to learn, I know it's hilarious, right? But if you really
It
want to
is,
learn
right.
about what you're doing, get into some of the more vetted sources. You know, I've reached out. I was telling you, I've reached out to Chief Bashor, who retired out of PG County, and you know, I think he's got a wealth of knowledge, and I love to have conversations with him. And you know, there's folks like that all over the industry. You know, this is an aggregate of everything that I've been able to amass in the last number of years, and I've been lucky enough to meet the right people and be in the right situations to be able to tell more people about where to go and what I've learned. And I hope that it helps someone make a better decision. And it's an open book. Anything that I've learned, or can I learn more? I'm ready to go. But but I would start with those resources at least.
Well, good. And how would they contact you if they want to reach out to you for questions?
I've got a couple emails. wmarshall@fullcirclelithium.com or wmarshall@ffcancer.com. I'm currently the director of research for the Firefighter Cancer Foundation, and I'm in charge of research and development for Full Circle Lithium for lithium battery fire suppression. And either one of those is the best way to reach out. Anything that I can do to help anyone in the industry with respect to thermal imaging, with respect to lithium battery fires, or chemical research, chemical protective clothing, things along that line that fall into this. That is what I now do. I was a full-time firefighter with Gwinnett County, had an awesome almost 14 years with them. And after 24 years in the fire service, pretty much paid, now I'm volunteering part-time, and I'm dedicating my time to chemical research and lithium fire, basically energy fire suppression, to try to move the needle forward and help folks learn.
We lose you? Oh, I think we got you back. We lost you briefly there at the end. You still there?
Yep.
We may have lost. Okay, there you are. Okay.
Yep.
So we want to thank you for your time today, Webb, and all your experience. I hope to do more with this as well. Maybe we can do part 2 on different specialized subjects. Those of you who have watched, you can check out our resources on YouTube. The center QR code is a Seek Thermal link. All the webinars we've done are placed there. This one will be uploaded once it's processed. The presentation you watched today, if you scan the QR code on the right, it will take you to a free Google Drive. You can download it along with some additional videos that Webb's provided just for your general usage in education, but always seek out education and training. These are very complex subjects. We don't want people to go in this without proper training and education. And I want to thank you for your time today, sir.
Thank you for having me. It's been a blast talking about it.
Oh yeah, I think we could do several more of these. So hopefully we will. And I look forward to seeing what you do in the future of the fire service. If anybody needs to contact me for questions, you can go to our website and hit contact us, or my email address here. My phone number is listed there. And as always, we're sharing stuff on social media every day. We want to say thanks Seek Thermal for sponsoring this and allowing us to provide free training to you. Each year, we're providing more and more free training thanks to our partners. And this is all made possible due to their support. Jordan, we want to thank you, and I'll let you close it out.
Thank you both. Thanks, Webb, for coming on today and being our special guest. Thanks, Andy, as always. So, guys, if you have any further questions about after this webinar, feel free to reach out directly to Andy, Webb, or myself. We'd be happy to answer any questions you guys have. Like Andy said and Webb said, if there was something that Andy mentioned or Webb mentioned that you want to go back and reference, I will be sending out a recording of this webinar to everyone who registered. So even if you weren't able to make it today, if you joined late, if you want to go back and reference something, a webinar recording will be sent out to everyone within the next day. Thank you both for your time, and thank you for everyone who registered for today's webinar.
Thank you very much, Jordan.